Hello, everybody. This is Mr. Sanford. I'm going to go through your 3.0 examples today. So we're going to start off with number one. It asks you how many oxygen molecules, O2, are in 3.36 grams of O2. So to start these problems off, we're going to need to begin by doing a pathway. In order to do that, you're going to need to look at your pink mole map on page 40. Here's my copy. So we're going to need to find a pathway. We're starting with grams, which would be mass down here in the left corner. And you're being asked to convert it to molecules, which is up here in the top left corner. So to get from mass to molecules, you have to go through moles first. So we should be able to create a pathway from that. We're going to start with grams. We're going to change those to moles. And then the moles we can change to molecules. All right, so to begin the problem, after we get our pathway, we're going to start by writing down what we're given, 3.36 grams of O2. And we're converting this, so we're going to start our problem off by using times in a line. And we know that we want to get rid of grams, so that should be on the bottom part of our conversion factor. So, but how many grams? That's the question. So this is where our periodic table on page 16 is going to come in handy. So we're going to need to take oxygen, and it's O2 this time, because it's one of those diatomic elements that exists as 2. And we know that the molar mass of oxygen is normally 16 grams, but since there are 2 atoms, we multiply that by 2 to get 32 grams. So that is what we're going to plug in to our conversion factor on the bottom again, so grams cancel. And we know that 32 grams of O2 is equivalent to 1 mole. So using our first step, we're going from grams to moles, so we want moles on top. And now we can cancel out units that are on opposite sides of the fraction. But we're not done with this problem. We still need to go from moles to molecules. So we set up a second part of the conversion, so times in a line again. And now we have moles on top, so we want to get rid of moles, so we put it on bottom, 1 mole. And we know that it's equivalent to Avogadro's number of molecules. So 6.02 times 10 to the 23 molecules will go on top of our second conversion factor. And now again, we have the same unit on opposite sides, moles, so we can cancel. And now we have just simple math that we can do. So 3.36 times 1 over 32 in parentheses times 6.02 times 10 to the 23. And when you type 6.02 times 10 to the 23 into your calculator, don't forget to use the second E function. So you would type it literally 6.02 second E 23. And your calculator should tell you that this comes out to 6.32 times 10 to the 22 molecules. The second problem I'm going to do is oddly number 2. So this problem asks you to find the mass in grams of 2.00 times 10 to the 22 formula units of iron 2 fluoride, Fe2. So we need a pathway here as well. So let's look at our mole map. We're starting with formula units this time. So we're starting in this top left corner here. And the only thing we can convert those to that could get us to grams is moles. So those formula units will be converted to moles, and once we get to moles, we can go to grams. So we'll be able to finish out our pathway. So formula units to moles to grams. So let's start off our problem. Let's write down what we're given, 2.00 times 10 to the 22 formula units, times in a line, because this is a conversion factor. And now we need to get rid of formula units, so we know that goes in the bottom of our conversion factor. And we're going to be converting those formula units to moles, so that goes on the top of our conversion factor. And we know that 1 mole is equivalent to 6.02 times 10 to the 23 formula units. So that goes on bottom, so we can cancel 1 mole on top. Now we have the same unit on opposite sides of our fraction, so we can cancel those units. But we're not done. We've gone from formula units to moles, but we need to take those moles and convert to grams. So we set up another conversion factor, times in a line. We want to get rid of moles this time and change them to grams. So moles should go on bottom. And now we need to put grams on top. But first, we need to figure out how many grams are in 1 mole of FeF2. So to do that, we'll have to find the molar mass of iron 2 fluoride. So we'll do that down bottom. Iron 2 fluoride, FeF2. So we have 1 atom of iron, 55.85 grams from the periodic table, rounded to 2 decimal places, times 1, since that's the subscript here. We're going to add that to 19, the molar mass of fluorine, rounded to 2 decimal places, times the number of atoms of fluorine. Since the subscript is 2, we're going to multiply by 2 here. So when we do the multiplication and the addition, we should find that this comes to 93.85 grams. So we're going to plug that in here on top of our conversion factor. Now we've got moles on both sides of a fraction. We can cancel those out. And we can now use our calculator to solve this problem. So again, remember, when we're doing scientific notation, we have to tell the calculator that it's scientific notation. So use the second E function. So you would type in 2.00 second E 22 times parentheses 1 divided by 6.02 second E 23 parentheses times 93.85. Hit enter, and we should find it comes out to 3.12 grams. And I'm going to round to the second place after the decimal to coincide with the number of sig figs that I started with here. So 3 sig figs here, and I'm going to do 3 sig figs in my answer. The third problem I'm going to do for you is number 3. This one asks you to find or to determine the number of molecules in 12.2 grams of nitrogen dioxide, NO2. So we need a pathway to start again. So let's look at our mole map. So we're starting with mass this time. So we're starting in the bottom corner again. The only thing we can change that mass into is moles, right? So once we get moles, we can then convert to molecules, which is what they ask us. So that completes our pathway, grams to moles to molecules. Now we start our problem. We write down what we're given, 12.2 grams. And we're converting, so we need times in a line. We need to get rid of those grams. So grams goes on the bottom, and since we're changing those grams into moles, moles will go on top. But we got to figure out how many grams. So we're going to use our periodic table to get the molar mass of nitrogen dioxide. Nitrogen, its molar mass rounded to 2 decimal places is 14.01 grams times 1, since there is only 1 atom of nitrogen in this compound. And we're going to add that to the molar mass of oxygen, 16.00 times 2, since there's 2 oxygens there. So after we do the multiplication and the addition, we should find this comes out to 46.01 grams. I'm going to plug that in there on the bottom of our fraction, so grams cancel. 1 mole goes on top, and now you can cancel out the grams. So we've gone from grams to moles, but we still need to go from moles to molecules. So we need to set up another conversion, so another times in a line. This time we have moles on top, and we want to get rid of that, so we're going to put them on bottom here. So 1 mole, and we want to find molecules, so that needs to go on top. And we know that 1 mole is equivalent to 6.02 times 10 to the 23 molecules. So we plug that into our top. Now we have moles on both sides of a fraction. We can cancel those out. And now we simply use our calculator to do the rest of this problem. So you would type 12.2 times 1 or parentheses 1 divided by 46.01 parentheses times 6.02 second E 23. Enter. So this should get you 1.6 times 10 to the 23 molecules.